All right. So before I really start, I want to make sure that everybody can hear me and everybody can see my screens.
Yes, I can.
Okay. Awesome.
Good to go.
Okay. Cool. So welcome everybody. I'm Fernando Tomlinson. I really appreciate the opportunity to speak. I really am thoroughly impressed with what you all are doing in the community, and it's for a great cause. So I feel it's only my duty to do my part in helping with this. So, welcome to this talk. I call it Artifactually Speaking Residuals in the Registry and Event Logs. All right, so a little bit about me. I'm a CISP, been a CISP since 2015. I have 19 years with the Department of Defense, namely the Army, where a number of my coworkers are online and other people that I've worked with in the past. I'm a cybersecurity adjunct professor at a couple of schools, one of which local in the community, Augusta Tech, and I'm certainly a PowerShell enthusiast. As such, I enjoy coding within the language and have developed a number of red and blue team tools. I'm a co-author of a book, PowerShell Conference Book Volume 2. I highly encourage you to support the book. Any proceeds that are gained from the book don't come to any of the developers. Instead, it goes to underrepresented, underprivileged individuals trying to get their start in cybersecurity. And I think that kind of hits home with all of us, right? Because at some point we had to get some start in what we're doing today. I have a couple of presents, if you will, on the internet, and those are some sites in which you can connect. Okay, so looking at the agenda, I hope to cover a number of things, right? This is an oldie but goodie in the sense that it never gets old. This is very focused on Windows, if you haven't been able to tell, right? And this is talking more or less about artifacts in the registry, in the event log, from a red team perspective and a blue team perspective. There's a couple of instances where an artifact can satisfy both red and blue, but in other cases it's a one or the other type thing. Now, as I go through this, based upon my experience and exposure, I'll present a couple of things in which I can actually present, but I want to put this disclaimer out there. And for some, you might be able to read that. For others, you need the too long didn't read or really too small couldn't read, and that's this. This presentation isn't suggesting that you should only bypass or analyze the registry or event logs, but I'm merely highlighting a small amount of the plethora of information that we can gain from them, right? So keep that in mind as we go through. Okay, so starting off, we'll talk about the registry and then we'll kind of get into some event logs. So the registry, at the core, it's the DNA for a Windows machine. So when we think DNA from a human perspective, we can almost account and really say the registry is that from a Windows perspective. It's a hierarchical database in which information is stored and retrieved based upon processes and software that's installed, and it contains things like software programs, hardware, user preferences, and a substantial amount of other data. Out of all those things that I was just talking about, the thing that constantly came to mind for me was that, holy cow, this seems like a gold mine for forensics analysis. And it truly is. It also is a gold mine from a red perspective where I'm trying to inflict some pain, if you will, or inflict my will on an organization. So the registry itself is broken down into a couple of components, but two of the most important ones, in my opinion, is that the registry is truly only complete when it's loaded into your memory, right? And as we boot the machine, we have these hives that are on the machine that get loaded into memory each time. And we've got a slide that really starts to differentiate that and what that looks like. Now, when these hives get loaded into memory, this is about the time in which they're available to us. So when we start to browse the registry, it's because they're already loaded from something on the system, put together in some form of fashion, in which it's now available for us within the registry. From this perspective, there are some registry hives that only exist in memory. They don't map to anything on the disk, and vice versa, where there's some that generally, historically really, come from the disk and then get formed into a live hive, if you will, once the system is booted up. So what are these hives that are on the disk? Well, they're default, which really speaks to a system level user, if you will. So we'll say that, and then we'll put that off to the side. We have SAM, and SAM is where we have things like local user configurations and settings, more or less the user accounts, the groups, and passwords in an encrypted manner. Okay, so that's good to know. We also have security and security and software. And then this starts to really speak to software that's installed on a machine. There's settings and other configurations that are stored in the registry. And during the process in which this software is operating, the registry is consulted for some of these configuration settings. Now, it's not the only place, but that is a location. We have system, and when we look at services that are running on a Windows machine, they all point back to the registry. You'll see some maliciousness that we'll get into here shortly, in which we're going to take advantage of how that process works with services in Windows and how we can affect and really bypass parameters by taking advantage of stuff in these system hive. Now, if you're on a Windows machine and you're like, oh, okay, I'm starting to pick up what you're putting down, on disk, they reside in System32 config. System32 config. Now, if you try to go there now, live on your machine, and copy them or move them, you won't be able to because they're locked. They're locked because they have a handle, or they're open, and they're open in memory. So we can't actually affect them in that manner. There's a couple ways we can get around that, but another method in which we could grab these things are roughly every 10 days or so, there's a backup of these registry hives that are sitting in the config folder in a folder called regback, right? So that's pretty cool. That becomes another place in which we can get stuff. I say this because I imagine myself as a defensive person or an offensive person, and if I'm able to identify stuff, I don't know, today, February 24th, and I'm trying to understand, maybe in one form or fashion, was it there 10 days ago or about 10 days ago? Well, let me go look at one of those backups, and then I can continually walk the dog on that to get some type of time frame in which something appeared. Now, there's some write times that are associated with some of the keys in the registry, and we'll look at that as well. But from a forensics perspective, we're really just trying to take whatever we can find to help paint a picture. From an offense perspective, I need to be cognizant of this, and if I'm dealing with a not so well-equipped admin, well, maybe I don't care. But if I'm dealing with a sophisticated top-tier admin, then I probably want to be cognizant of this and probably look for how do I lessen my footprint or clean that up later on. We also have user hives that are on the disk, right? So these system hives, this is at a system level. No matter who logs in, this is directed towards the system at large. Then we have user-specific hives, and these are ntuser.dat and usrclass.dat. And ntuser.dat, we see where that's located. Conveniently, it's located in everybody's user's profile, and it's called ntuser.dat. So if Fernando is logged on right now, and I navigated to that folder, and I wanted to affect that file, well, I couldn't because it's loaded live in memory, and it's locked. But guess what? If somebody else has a user account on my system and they're not logged in, as long as I have the applicable rights, I can absolutely navigate to their user profile and I can grab that ntuser.dat and do something with it. We're actually going to walk through that from a screenshot perspective of how that might be done. And from a user class perspective, there's a subset of key information that's also stored here. So we have not really an overflow, but an additional hive that's tied to the user. We see that this one's a little bit more buried down in app data local Microsoft Windows. All right, so high level from disk to memory. So we have those registry hives that are sitting on the disk. There's some process that happens, and in this case, Windows boots or starts up, or a user logs in, and then those hives get loaded into memory. into memory. Again, they may reside on the system, but when the system boots, the process then loads them in memory and they become locked on the file system. As we see the user one, well, this is based upon the user logging in, and then his user hive gets locked and loaded into memory as well. Okay, so this hive transformation. If you've never looked, well, you could open up your favorite version of Windows, and you can, in the start search area, you can type in reg edit, right? REG edit, and then hit enter, and the registry viewer will open. This registry viewer allows you to interact, see, read, alter in some cases, contents of the registry hive that is now loaded into memory. Now, these hives on disk, when they get loaded into memory, and we look at them in registry editor, they become something different. So, case in point, my NT user in user class, USR class.dat, while that's the name of them while they're on the file system, when I look in the registry editor, they're now known as HKey current user. Those system level hives that we talked about, system security software system, I feel like I said that twice, when they're loaded into memory in registry editor, we see them as HKey local machine. Now, Windows has this feature, and I hate saying feature because sometimes a feature in Windows is not really a feature, it's a, okay, never mind. But when I'm logged in, you might have heard of a feature called switch user, right? That allows essentially a person to background my session, but then they log in. Well, when we do switch user, my HK current user now becomes HK users because I'm not totally logged off. So it moves my personal user hives from current user to just users. And then the person who logs on, theirs get mounted as current user. All right, so here's a visual breakdown. On the left, we have these hives, as we just talked about it. So you see HK current user, you see HK local machine, and then these hives have keys. Those keys, all of them look like folders, and each key may have a subfolder. So on the left-hand side, we have the hives, keys, and subkeys. On the right-hand side, we have values. So for each one of the keys or subkey, there may be a value. In this case, the value may have a value data. 1, 0, maybe some ASCII text. This is where it starts to get good and juicy if I'm an offensive-minded person in the registry. But this is also where it becomes a daunting task if I'm a defensive guy. Because how am I supposed to know every registry key, but then also understand every value and value data? It's a tough task, right? Because when I install software, there may be certain registry keys and values that get made automatically in that installation process. By virtue of me doing things on a machine, there may be things that actually are taking place in the registry. So again, we go back to how do we know? Well, the best way for us to know is, one, have some type of alerting in which we're monitoring for keys, but then that could be timely because so many things are happening in the registry just by virtue of us doing business on a Windows machine that we could inundate ourselves with it. The other thing we can do is be cognizant of well-known keys and where artifacts lie. And that's where we really start to break down and get into it. So how is this data stored? Well, some of it is stored as a binary. Think of an executable, if you will. Some of it is stored as an XML file, just subset of text. Some of it is even stored as ROT13. Think of ROT13 as character shifting. So if I had a text of A, B, C, D, I would just shift them to the right 3 letters, and now my A becomes B, C, D, E, and then I just kind of carry that on. This is interesting because this is one of the ways in which Windows tries to protect itself. In a large laundry list of registry keys and registry hives, some people just want to Control F and search for keys throughout the registry. Well, when Windows is using ROT13, to encode, alter, if you will, the keys. Simple texting or simple filtering and using the find command isn't going to help us. Not every key is in the same format, but for a ROT13 perspective, we see things like user assist. And user assist helps us understand executables that were executed on a machine. And we'll talk a little bit about that here in a minute. Now, the keys themselves are tagged with the last update time. The format is Windows 64 time, and that's really a version of time. I won't really go into that, but just know that as the keys are updated, there is a last update time associated with it. What's horrible about that is by default, we can't view that in that Windows Registry editor that I had on the previous slide. But there's a way that we can actually get it. In some cases, we'll have to export the data. In other cases, we'll have to use a third-party tool. But have no fear, we can get that data. All right, so why would somebody even care about the registry? Well, plethora of information. So much data about a machine is there. Again, executed programs, access files, and the list kind of goes on and on and on. It's heavily used by the operating system. We know this because we recognize its DNA. So as I am doing things in the grand scheme context of my day, I'm altering things on the registry unbeknownst to me. So, people have the ability to store malware in there. We'll look at that as well. But they can also use it as a staging area for other parts of their campaign. If I have a large piece of malware that may be 15 megs, that's not necessarily big in the grand scheme of things, but trying to put a 15 meg file in ASCII text or base 64 in the registry is large in that nature. Maybe I'll dial it down to a stage 0 or a piece of malware that its only purpose is to reach out and grab something else, right? So because the registry is so large and because there's not anybody that I know of that can tell you every key about in the registry, it becomes a great place. And honestly, I like to say this because I did a brief at Microsoft in Charlotte, and I brought this up, and I had a room full of engineers, and people were like, yeah, I don't know anybody who knows everything in the registry. And that just tells you something, that if we're talking to a room full of Microsoft employees and they themselves don't know people who know everything in the registry, the red light bulb in your head may come on and be like, okay, well, that's a good place for me to do some maliciousness. So from an analysis perspective, how can this help me? Well, I can answer the question of did malware or something suspicious execute? If there is some form of persistence, I may be able to get that from within the registry. I could understand what files and folders were accessed. So from an analysis perspective, based upon the well-known keys that we know about, we can answer those questions, and that's rather helpful for an analyst. So if we looked at a methodology of sorts, understanding that the green aspect talks to the registry hives that we have on our system, well, what can things like the SAM hive provide to us? Well, it can help us profile users, how many users are on there, how many times have they mistyped their password, do we have users that were created and then they were deleted afterwards. We have users that were created and never logged on, right? We can start to profile users on a machine, local users. From a system or software hive, we can start to understand system configuration and how that's arrayed, especially if we're in an enterprise and we're talking endpoints. You'd imagine that endpoints in an enterprise would all be replicated and duplicated, so they all should be the same. And you start to see a lack of commonalities in there. That sounds like an anomaly. In which probably warrants a little bit more attention. From a system software perspective, if we have inclination that there's some close access concerns, then we can understand who's using USB drives and a number of other peripherals. If we want to understand that, hey, I know this machine has malicious logic on it, and it's communicating with known malicious servers, then we can then certainly look for user activity based upon an individual's user hive, right? Because from an individual user hive, I can start to understand what items that they were individually doing. And now, if I see a user hive that belongs to the persona Fernando doing some malicious stuff, If Fernando comes back and tell me it's not him, well, now guess what? Now I'm just in a place where I need to prove it. Because if I can put Fernando, not the persona, but the physical human, at the machine, and then other artifacts like, hey, this is how they logged in, was it remote, was it interactive, and a number of other things, and I can not correspond, but correlate that with what I'm already seeing, well, that's just super helpful for me. All right, so what are some of the tools that we can use to help us in this endeavor? Well, Registry Editor, which we just talked about, this is inherent to Windows. It lacks some features, namely the last update, right? So we have things like RegRipper, and this is going to help us with offline files. So you can take one of those registry hive that we talked about from a offline perspective, and you can feed it into RegRipper, and it will parse it out, and it will look for things that are well known and present to you a makeshift report, if you will. There's also plugins that are available, and you yourself can also make plugins as well, so you can make it as extensible as you want. Now, with any type of automated analysis, we may not get everything that we care about, because it's all up to the individual who is writing the tool to then determine what is relevant for us to actually get and what not to get. So in this case, we may have a gaping hole in which we're missing stuff because of that reason. We have Registry Explorer, and this can help us see deleted keys. Maybe I'm doing stuff in the registry, and I'm trying to clean myself up, and I delete my artifact. Well, when I utilize something like Registry Explorer, I can see those keys being deleted, and we actually have a slide coming up kind of showing that. We have Yaru, yet another registry utility, and it also can retrieve deleted keys. It's a phenomenal tool, very rich in feature, but it costs money. Registry Viewer, this is a tool made by the same folks who make FTK. So if you're familiar with forensics, FTK is a forensics tool, well known at that. And this is a registry viewer that is made by those individuals. And by virtue of it being made by FTK and it being awesome, Registry Viewer also becomes awesome as well. PowerShell, inherent to a Windows machine, so we can utilize that programming scripting language to do some analysis in the registry. So this is a very quick list. It's not an all-inclusive list, but this gets us started with reading the registry and trying to get after the task. Okay, so the next couple of slides is really us talking about specific registry areas, where they're located, and kind of like what it provides to us. So if I'm looking for evidence of execution, right, I can look at MUI cache. And this is going to be stored based upon every new application that's launched. And we see the screenshot down below showing it. So I'm able to see each one of those things being launched. It doesn't, however, log the actual execution time. So I would then need to be able to utilize one of the tools that we talked about that helps me with the last write time to then be able to make some correlation into when it actually executed. We have shim cache, and shim cache is really made from a compatibility perspective, right? So if you've ever been messing with the binary and maybe it crashes in your Windows 10 machine, but it used to work in Vista or XP, and there's a compatibility feature that you can manually force it to run under. Well, shim cache, when it's invoked, either compatibility fixes on its own, it gets logged there. Well, when it gets logged there, what are we getting? We're getting the file name, we're getting the path to the executable, we're getting the last modified time of it, last execution time, amongst some other things. Now, the bad thing about this is if I'm defensively minded and I gain access to a machine, I'm not going to see this stuff at that time for the current session, because this only gets written at shutdown. So if I'm doing offline analysis where somebody has given me a disk drive, then I'm good to go. If I want to see this off a live machine, well, I'll need to dump memory to be able to get that out of memory. But both of those, solid. We have user assist. We've talked about this kind of briefly. This is going to track our executables and links that we open in Explorer. So think of Explorer as your graphical representation when you log into the machine, but also think of Explorer as File Explorer, right? So largely speaking, everything that we execute, we should see in user assist. With the right tool, this is going to tell me the last time and the number of times that the application launched. Unfortunately, this is stored as ROT13. And I wish I had a screenshot here so we can look at some of that ROT13. We would best do analysis for this key in a third-party tool, one of the ones that we talked about. We also have recent apps. This is more of a new thing for Windows 10. It's going to track all programs and files that we access. And this is very similar to user assist. From a red team perspective, people are less likely to mess with this and cleaning up their tracks because of how fairly new it is or fairly untalked about, right, in this field. Now, what's interesting about both of these is notice the beginning path on the beginning line of each of them. HKCU, that's current user. When you see current user, that's an individual. So individually speaking, we're able to see what programs an individual opened. Individually speaking, we're able to see the recent apps. So even if I were saying, hey, something happened on this computer, well, I can look at the user's registry hive to then understand which of the personas actually executed it. So this is key artifacts from an individual perspective. When we look at trying to do some form of an investigation, we have shell bags, and that's going to sit in the current user again. This contains the path, last write time of every folder that's accessed, right? This requires some interaction with the shell. So think of shell not like a command line shell, but shell from a GUI perspective. So this is good. I might not be able to understand what binary they actually touched, but the fact that they went into a specific folder gives me some leadway, and then I just need to understand what's in there. Especially when we talk about having a smoking gun. It's one thing to have a single source report, if you will, of something that happened. It's another thing to be able to back it up with other information that supports what we're talking about. We also have recent docs, right? A little bit different from the other recent one that we talked about. This is going to track the last 150 files and folders that were opened. And we see, again, this is based upon the user's profile. So from an investigative perspective, we start to see aspects in which we can utilize for investigations. We have most recently used. This will also go down by application and log what things were actually executed. So when I go and I look at .docs or Word, I'd be able to see what Word files were opened. Same thing with PowerPoint. So we'd be able to see this from a bucketed perspective, all within the most recently list. Again, notice where that's at. That's from a local user and not something that we then have to understand with the system at large. We can just look in the user's hive to make that determination. If somebody's using the File Explorer and they're searching for something, well, guess what? That's going to be logged in Word Will Query. Again, local user. And from a system perspective, we have the ability to understand what programs are installed, because the same way we install them, there's also a key that stores information about how to uninstall them from a command line perspective. So in HKLM, local machine, that's everything on the machine, we're able to see that. Stuff like the names, the versions, the install dates, right? We start to get an understanding of what programs are actually installed on the machine. Typed URLs, again, from a local perspective from the actual user. Last 25 recent URLs. These are URLs that they typed in. I shouldn't say URLs, but that's what it's called, within Internet Explorer and in Edge, but also within File Explorer, right? This is going to help us because it starts to tell us where this person was actually trying to navigate to. We get the last 25 from that perspective. We also get typed paths. So in the same respect, where they're typing paths to get somewhere within Explorer as well, but not within Internet Explorer or Edge, we're seeing where that person is actually typing it in. I imagine a time in which somebody has malware on their machine. We're now trying to trace it back, and we see it happen under a particular user who's logged in. The user may claim they didn't actually navigate out to a website, but instead they got redirected from a different site. Well, we can utilize things like typed paths or maybe typed URLs, more so typed URLs, and see that the user clearly typed it in, and that's how they got there, as opposed to them being redirected there. Right? So all these artifacts are very helpful in that respect. Mapped drives, so as people start to map drives, we're able to see that. That's in the registry, and that's right under the user's Hive under network. So per user, we can see what drives are mapped. All right, so here's type paths in play. So we see at the top, I have some recent docs, if you will. So we see demo.dll and we see GitHub, but because I've typed those in there, notice at the bottom screenshot, we have type paths, and out to the right, they populate there. So they're going to populate in two respects here. Recent docs, but also in typed paths. And this is going to keep, we said, the last 25. Now, nothing stops somebody from going in here and deleting them. However, if we're seeing stuff in recent docs, but not in typed paths, we can start to make some correlation and some assumptions that somebody was trying to clean up because they left artifacts elsewhere. All right, so looking at persistence, there's many ways for us to do this. We have run keys. This is the classic way in which somebody does it, i.e., when I configure a run key in the registry, when that user logs in or when the system boots up or anybody logs in for that matter, execute this program or execute this item. That's classic. We have application hijacking. So essentially when a particular event happens, we'll run whatever code we want. We have some browser helper objects, essentially us taking over or taking advantage of how the browser actually works. We have some very intuitive ways where a admin could configure a log off script. So every time somebody logs off a machine, it executes a script where it does something. Maybe the admin wants to delete the recycle bin. Maybe the admin wants to check for updates beforehand, whatever. But there's a registry run key called run once. And when we configure run once, it does exactly what it sounds like. It runs once, and then it deletes the item that's in there. So we can use a we can use a log off script that as somebody's logging off, creates a registry run once configuration, and then when somebody logs in, it will execute whatever malicious code we have. In this case, I just put stager execution, and then when it executes that, it deletes the run once. So now if a DCO person was coming by later on trying to look at the classic run keys, well, nothing's in there. And then guess what? When that user gets done and they log off, it then pre-stages itself for the next time somebody logs in, right? So pretty slick in that manner. All right, so here's some persistence through offline registry, right? So if I'm logged in and there's another user who's not logged in, if I have the applicable rights to navigate to their profile, well, I can utilize PowerShell and I can essentially map their registry hive in a way in which I can alter it. So this is what we're doing here in PowerShell. We're going to create a drive so PowerShell can interact with it. And I like to do this via command line because when you think of most folks who are malicious in nature, they don't necessarily have a GUI in which they can do this. They're traditionally doing it from the command line. So once we load that drive and it's something we can interact with, we then load their user hive. So notice I'm using reg load. Reg is a built-in Windows capability. And I'm saying, hey, load it in current user under a key that I'm just calling 123. I'm just making something up. And the thing that I actually want to load is the ntuser.dat at this location. And then I want to come in here and I want to create a new key. The new key that I'm going to create, I just call it evil key. And then I want to come in there and I want to create a value. Remember, value was on the right-hand side. The value is going to be essentially called totally legit. And then I'm going to give it a value data of that executable. And then I'm going to clean up and unload it from my current session. So now when that user logs in, I've now created persistence in there. Their hive is going to load. and it's going to execute on my behalf. And I'll pause here. I wanted to wait till we get done with the registry, but I'll pause here because I want to make sure that if you have questions or anything, that we have an opportunity to answer them. And what I failed to do was I like to do these back and forth. So if at any point you have a question or comment, stop me in there because I want to make sure I'm answering it. So I'll pause here. Any questions or comments from the field? Okay. Okay, awesome. Nothing heard. So we also have the ability to do some persistence and execution. So in this case, we're going to take data. Let's say the data is called, in my example, the second line there, where it says bytes, I'm actually taking calc.exe, which is calculator. I'm taking that executable, and then I'm going to convert it to bytes, a sub-series of numerals, integers. And then once I have those bytes, I'm then going to convert it to base 64 encoding. And once I have this base 64 encoding, well, I'm going to create a registry key that has a registry value. And for the registry value data, I'm going to feed it my base 64 string. And now it's just sitting there. It's sitting in the registry in a place that's obscured, in a place in which admins won't find me unless they're purposely looking for me. And it's going to sit there until I'm ready for it to execute. This is a common technique in which people do this, and it's not only in the registry, but they can do it pretty much anywhere in which you can store data on a Windows machine. So we got Active Directory, event logs, alternate data stream, whenever, wherever. So the process to then convert it to bytes, base 64, and store it, we see before us in the top group, but notice I'm creating my I have a key, 7-zip, and I'm creating a value called updater64. Because maybe updater64 is a little obvious, but generally when you put 32 or 64 appended to anything, people think it's legit. It feels good, right? Oh, yes. What is that? Oh, it's the 32-bit version of whatever. Oh, okay. You just got that because it just sounds like that. And then I'll put that base 64 string there, and it'll stay there. Right? And maybe I have some other process that kicks off, and its only job is to read this key, read the data, reverse the process from base 64 to bytes to data, and then execute it, which is what we see on that bottom subset of text. So 4 lines, essentially 4 lines to hide it, 4 lines to reverse it and execute it. Here I'm doing it with calc.exe, but really you can do it with whatever you want. All right, so looking at deleted registry keys. So in this case, we talked about a couple of tools that allow us to do it. We're going to go in and we're going to delete them. And this is the screenshot is a copy from the previous one, but at the bottom, notice how we have cover our tracks, right? So I'm going to go in there and now remove it. Well, utilizing one of those third-party tools, I'm able to load the registry hide. And notice how we see 7zip64, and off to the right, we see my value of updater64, and we see my base 64 string. So while I went in there and deleted and tried to clean up, there's still an artifact in which somebody can then go in there and find me. The interesting thing about this, as we talked about last write time, is I can't do that inherently, but in one of those third-party programs, we can. So we see the last write time, i.e. the time in which I deleted it, was at that date shown before us. Okay, so this is good because I see where an actor could cover up their tracks, but I also see a way in which I could highlight this and find it. Yes, when we look at individual systems, this becomes an easier task. When I'm looking at an enterprise of machines, well, you might as well get you a Snickers. This may take a while, right? We got to get a little bit more diligent in how we're doing that. So here's some more useful keys from a red team perspective. In the registry, we can see all the firewall rules that are applied, and we can simply go in there and remove those firewall rules, right? All from the registry. We can carte blanche disable the firewall, right? We can also downgrade our version of PowerShell. Modern versions of PowerShell has a large subset of security built in, and then older versions of PowerShell, not so much. So what an actor likes to do is they like to downgrade to the older version because there's no security. But from a blue team perspective, we can disable that. And then for everyone out there, you might have used sysinternals, right? So like auto runs, PS exec, they're all great tools. But the very first time you run one of those tools, right, what does it ask you? It presents you with the EULA, and you have to accept it. And then the next time you run that very same tool, do you get presented with the EULA? No. Well, how does it know that you accepted it? Well, that registry key right there is where it's logged. So I imagine where Nando, malicious in nature, I get on a machine, I'm now trying to figure out what I'm going to do next. If I can understand that the organization in which I'm going against is already using something like PS exec, something made for an admin to access other machines, but commonly used by a red team person to do the same thing. If I can understand an admin is already using it, well, I'm just going to use it as well, because that becomes one less artifact that I'm creating. If I'm in an environment that they don't use sysinternals, and specifically PS exec, if I choose to use it, I need to clean up later on, because that squarely becomes an artifact in which people can look for. So when logon and really user init, when we go to log on to our machine, there's a process that kicks off. Largely, it's going to be explorer.exe, and this is what presents us with our desktop and all the graphical representation. If you were to go into the registry key and look at that that value, and edit the value data and say, hey, explore, which is already there by default, if you were to put a comma and then put in whatever program you want, when that system boots up, it will not only load Explorer, but it will also load whatever else you want. How great is that, right, from a red team perspective? And commonly, we're doing the same thing with user init. When we look at processes that are running, there's a verbose command line logging that is now kind of more or less the standard in Windows from a Vista and newer. Well, from a red team perspective, we don't want that logging, so we can, if we're in the registry, we can go ahead and disable that, unbeknownst to the admin. I won't talk about prefetch at the moment because I'm trying to save some time here. But largely, we also have services, right? So when you look at the services that are running on your machine, you may think that each service that's running is shown as an individual process, and it's not. It's actually shown as SBC host. So if you look at the processes that are running and you see 5 SBC hosts or you see 500, not one of those is really the right answer because it depends on your machine. But for the services that are running, it's not a one-to-one match. It's a bucket of services that are running under the context of an SBC host. So when I am able to come into the registry and affect that, at the bottom of this bucketed list of services, I added my own service called helper. Notice at the bottom there on the right, I've added helper. So now what does that mean? Well, I then created the service called helper, and then I mapped, if we look at service DLL, I mapped a demo.dll. So now when I went into my services and I started the service, the process or the program that it will run will be my DLL. In this case, all my DLL does is pop out a text box that says hello world. Next week, it might say, it might be malicious software, it might be ransomware, it might be a number of other things that are happening, but this is how we start to hide ourselves within the registry. We can also kind of do the same thing with Microsoft Office, right? There's a key called perf, almost like preferences to performance, if you will, performance rather, that isn't talked about. There's no documentation. However, if you're looking at a program like Proc Explorer and you're running processes and you're monitoring all the calls, hey, this process started, it created this folder, it tried to read this registry key, it tried to look at this registry key, you can then find places in which the program is looking for things that don't exist. And this is one of those times in which Microsoft Office products are looking for this key that doesn't exist by default. So then what do? Well, you go create the key, because hard-coded in the program, it's going to look there. And when it looks there, it's just going to run whatever you want, whatever you have listed there. This is typically found when we're doing stuff like debugging. all too often, programs are running, they're looking for things that don't exist, but we, general people, don't realize that because we don't have access to it. All right, hiding data. We kind of talked about this where we can put stuff in the registry. You may say, well, what happens if an admin runs across this, sees that, and is like, hey, this doesn't look right. Well, what we can do is we can pad it with spaces, white space, right? And we pad it with white space. We have it say value data not set, kind of like it would at the top key there. And then the only way an admin is able to see it is if they interact with it. So one, an admin's not going to see it. Two, if they were to see it, the only way they see it in this case is if they interact with the key. This is us being a little bit more stealthier because we may find ourselves going against a different type of admin. All right, I'm going to skip through a little bit here. All right, so I'm talking about event logs, and event logs help us with things like what happened, when did it happen, what users, right? All these resources of sorts that happen. From an older version Windows perspective, they were .evt, and we see they're located in System32 config, along with the registry keys. In modern versions with Vista and newer, we notice now they're in WinEvent logs, right? And the extension has changed just slightly. If we want them to be stored somewhere else, we can change this data where? You guessed it, in the registry. All right, so the types of logs, we got things like security. This is going to be the most commonly used for forensics because it contains the brunt of all the data. All right, we also have application and service logs. This essentially is tied to applications and services. So we had third-party programs like McAfee or even Windows Defender or whatever other program. Any logging associated with it, we're generally going to find in there. When we look at the event codes associated with this logging, there is a laundry list of them. And here are some of the, I don't want to say most common, but yes, most common. And if Fernando had his way, the ones that I would pick on to have first, right? And if I could only have one, it would be that 4688 process creation. If somebody can tell me every process that's created on their machine, that's half the battle, right? Let's think about it. Malware needs to execute. So if you can tell me every process that's created, we're halfway there in some respect, right? So here's some registry keys associated with USBs and applications. Again, a long laundry list of them. Some of them are enabled by default. Others have to be enabled. That's some of the bad piece of it. But take an example, 4624. This tells us essentially how a user is logged in. It says, hey, a user was logged in, and we see a log on type. So it's one thing to see that Fernando.Tomlinson logged in via this event log. It's another thing to then look at the log on type. Well, how did he log on? Well, if it's log on type 2, then he logged on via the console, meaning he was right at the machine. That puts him in front of the machine. If it was log on type 3, then guess what? This was like some drive mapping. You know, when you access a file share at work or you're accessing another machine through SMB or file services, well, that's going to be a network log on. If it's batch, well, this is typically dealing with scheduled tasks, run as, well, think of this as kind of somebody elevating. And lastly, 10 is going to be RDP. So again, it's good to know somebody logged in. It's much better to understand how they logged in so you can then really paint the story of, how, when, where, all that other good stuff. All right, so locating some evidence, we need to be cognizant because if I'm looking at somebody who logged in, if it's not part of the domain, then it will be logged local to the machine. If it's part of a domain, then it will be logged on a domain controller. And we just need to know this because this helps us direct where we can get some of these artifacts. And that's one example of many other ones. All right, so here's a number of tools in which we can use to look at the event logs. Again, I apologize, I'm going a little bit fast now. We also have the ability from a blue team perspective where there's certain events that we just don't have the ability to log. Maybe somebody created an application in-house and it doesn't log. Or maybe we didn't enable process creation for whatever reason. This is good because somebody of red team nature, when they get access to a machine, that's one of the first things they're going to do. They're going to survey that machine. And they're going to try to understand what's already enabled. Okay, they have process creation enabled. Okay, I'm going to use something else so I can try to bypass that. Oh, they have this enabled. Okay, well, that's too rich for my blood. I'm just going to go to a different machine. But when we can create our own event logs, that's a game changer. In this case, we did. And if you look at the top right-hand corner of the photo there, we have an event log that we're calling 1337. This gives us an opportunity to make up our own event IDs as well. All right, so a method for us to do this is we can look at triggers based upon the event log. And this is post-exploitation, meaning I already have access to the machine, and we can almost look at this as persistence. So I have something that's monitoring, and every 295 seconds, so almost every 5 minutes, I'm going to read the event logs, looking for a logon ID, and I'm looking for where the logon ID was in the last 5 days, and it was a user of administrator. Where that has happened, I then want to go down and I want to go out to a website that I call ilovecats.com. I want to download a picture and I want to essentially open the picture, right? Replace the picture with some maliciousness. Well, why would you be monitoring for when an admin logs on? Oh, well, I want to try to get some higher rights, right? If I can make the administrator's persona reach out to a website, download something of my choosing, and then automate it in an automatic fashion, execute it, that then allows me to elevate my rights in such a way maybe I didn't have before. All right, so as we kind of get to the end here, I want to talk about a tool I wrote called Invoke Ghost Log. So this is a technique for altering the event logs, right, on Windows 7 on up. This is going to be a thing in which we give it a custom query in text. Hey, I want to look for this event ID at this time frame and during this time frame, and then those are the ones that I want to essentially remove from the event logs at large. So I can do this based upon ID, time frame, or both. Now, the bad thing about this is if there are logging services that are being disabled or stopped or whatever, then I might be writing an event ID in a different area. So I'd be able to wipe my tracks of all the bad stuff I did, but I could be creating another artifact that says the event log, if you will, stopped for a period of time. And from a red team perspective, it's going to be situation dependent on what do I do. Do I leave the artifacts there, or are they so detrimental that I need to get rid of them and just leave this other little artifact that, let's be honest, a admin may not even find, right? Now, this requires that I have system level rights, but nonetheless, I'm able to do it. I'm unable to scroll here. I'm trying to bring up. Okay, there we go. All right, so because I didn't get a chance to pray to the demo gods today, we're going to use a pre-recorded video, right? And I'll walk through it as it's going along. So here, before I start, we have the registry, event viewer. This is what's built into Windows. And notice off to the left, we have Windows logs, which are essentially event logs. And I'm looking in the security log. This is going to be a conglomeration list, and I have 4688 process creation, right? And that's the one that I'm really going to be going after. So I'll go ahead and start this, and we'll look at this. So I'm going to look here, and notice how I have netcat that's in the event log. So I'm going to import this code, invoke ghost log, and then I'm going to feed it essentially some text. The text that I'm feeding it is the process ID 4688 and then a specific time frame in which I want to get rid of. Okay? I'm then going to feed that to invoke ghost log. It's going to do its thing. I might be talking ahead of it. Okay, cool. So now I'm going to go back in here and we'll look at it and we'll notice that that particular event is no longer. Right? So we see that before our eyes where I just cleaned up because I made too much of a mess on my way out, right? And that code, if interested, that code is on my GitHub and you see it there. So as we wrap up here, the event logs, the registry, plethora of information. I mean, I'm at just over an hour and I really skimmed over the event log. We really scratched the surface, which really tells you that we can go really, really deep in this. There's a number of things that we can utilize from a defense perspective. There's a subset of things that we can use offensively. And from when we put them together and we understand it, it's really a dangerous thing. The same thing when it comes to event logs. So with that, I'm Fernando Tomlinson. This presentation in the next 30 minutes, it'll be at that website. Any other presentation I've done is at that website. And where there's video, you'll be able to see the video. Any open source code that I've done, you'll find on my GitHub. And I have a presence on Twitter if you want to connect there. But I'll pause here for questions. If there's no questions, then I'll pass it back over to the moderators. Thank you.